Hello everyone, welcome to the channel Unknown Physicist. Today we are going to see the third video in the paper Thermodynamics. If you have not watched the before videos, I am giving the link in the description. Please do watch. So we are going to cover these topics today. First law of thermodynamics, thermodynamic process, work done, PV diagram and sign convention. Our first topic is first law of thermodynamics. It is a version of conservation of energy. So let us take a thermodynamic system. Now we are giving some heat energy to the system. Whatever heat energy given, it will utilize in two ways. So one is to perform the work and other is to increase the internal energy, where du is the increase in internal energy and dw is to perform the work. So the first law is given by dq is equal to dw plus du. Here dq and dw are path dependent function, that is they are not exactly differentiable, whereas du is the point function, that is path independent function, it is exactly differentiable. So let me take for example a cyclic process. So for cyclic process, initial and final points are same. So du will be equal to 0. Substitute this, you will get dq is equal to dw. All of us know that is the ideal case for Carnot engine. So the amount of work done is independent of the path taken, that is it's a conservative. So the first law of thermodynamics states that the change in the internal energy of a system is equal to the heat added to the system minus the work done by the system, that is du is equal to dq minus dw. So dq is equal to du plus dw. Now internal energy is basically defined as kinetic energy of the system plus the potential energy of the system. This potential energy is neglected in the case of ideal gas, and these are the basic definitions for dq is equal to tds, dw is equal to pdv, du is equal to ncv dt. Next is thermodynamic process. The thermodynamic process is usually given by the relation PV power n is equal to constant. By substituting the value for n, we will get four different thermodynamic process. The first is put n is equal to 0, then your P will be equal to constant, that is isobaric. When your pressure is constant, it is isobaric. Then n is equal to 1, so PV equal to constant, so constant is nRT, so your temperature is constant, that is isothermal. Next n is equal to infinity, that is V power infinity will be a constant, so your volume is constant here. Whenever there is a huge volume, pressure is negligible, so V is constant, so that is isochoric. Next, put n is equal to gamma. Gamma is given by Cp by Cv, so PV per gamma will be equal to constant, that is adiabatic condition. So by substituting the values for P and V, we will get these relations. PV per gamma minus 1 equal to constant, P per 1 minus gamma, T per gamma is equal to constant. Just check it by applying it in the equation. So the next is work done. It is given by dw is equal to pdv. In integral form, w is equal to integral pdv. Now we are going to see the work done for our fourth thermodynamic process. First is isobaric. Here our pressure is constant. So w is equal to integral pdv. My limits are vi and vf, initial volume, final volume. So p is constant, so write it outside the integral. Integral dv will be equal to v. So substituting the limits, p of vf minus vi. So vf minus vi, since integration it is written as delta v. Next is isochoric. Here your volume is constant, so your work done will be 0. So these are the relation for isochoric and isobaric. Next is isothermal. PV is equal to constant. Our constant is nRT. So substituting the value for P, it is nRT by V. So taking out the constant outside the integral 1 by V. Integral 1 by V is ln V. So substituting the limits, our work done will be equal to nRT log Vf by Vi. Next is adiabatic. Our adiabatic is PV per gamma is equal to constant. In adiabatic condition, dq is equal to 0. So because your q is constant. Next, in the first law of thermodynamics, dq is equal to du plus dw. Substituting dq as 0, dw will be equal to minus du. That is, there is no loss or gain of heat energy. So dW will be equal to minus NCV dt. Sorry, I have missed the minus sign over here. So delta T is nothing but TF minus TI. So W is equal to minus CV TF minus TA. We can rewrite this as NCV TI minus TF. So next, before going to the next topic, there is a small thing. Gamma is equal to Cp by Cv. There is an important relation called Mayer's relation where Cp minus Cv is equal to R. From the before relation, substituting the value of Cp as gamma Cv, we get the values for Cv and Cp in terms of gamma. That is, Cv is equal to R by gamma minus 1 and Cp is equal to gamma R by gamma minus 1. We have been keep on speaking about gamma. So how you might wonder how to get the value for this gamma. So there is a formula where gamma is equal to 1 plus 2 by F, where F is your degree of freedom. So for monatomic, the degree of freedom is 3. That is only 3 translation is there. So gamma is equal to 1 plus 2 by F. So substituting the value for F, you get your gamma as 5 by 3. Similarly, substituting the values for gamma in Cv and Cp, you get the values for Cv and Cp. Please do work it out and get these values. So the value for Cv is 3R by 2 and Cp is equal to 5R by 2. These are very important for your problems in thermodynamics. Next is for diatomic. Your degree of freedom here is 5. That is 3 translational, 2 rotational. So gamma is equal to 1 by 2 by F. Substituting the value for F as 5, you get gamma as 7 by 5. So here again try it out. Cv is 2R by 5, Cp is 7R by 2. So in the next topic we are going to look is PV diagram. Here we will learn the easy ways to remember a thermodynamic process. So if it is a straight line, it is either isobaric process or isochoric process. Always be careful with the axis. They may interchange it to confuse you. So if it is a horizontal line, it is isobaric. Your pressure is constant and your work done is PdV. For if it is a vertical line, then it is isochoric. Your volume is constant and delta W is 0. So if it is a straight line, it is either isochoric or isobaric. Next, if it is a curved line, it is either isothermal or adiabatic. How to identify the curved lines? Always remember, slope of adiabatic is greater than the slope of isothermal. That is, dP by dV of adiabatic is equal to gamma times dP by dV of isothermal. In isothermal, PV is equal to constant. In terms of adiabatic, PV per gamma is equal to constant. So our last topic, sign convention. This is very important because if you do a problem and arrive at your answer, you may get confused with the sign. So sign convention is very important in thermodynamics. Let me give an easy way to remember. Remember, you have a balloon in your hand. Now you are blowing the balloon. So the final volume increases. That is expansion, work done by the system. Your final volume is greater than the initial volume. So it is positive. Now you are pressing the balloon. So the final volume decreases. That is compression, work done on the system. Final volume is less than the initial volume. Now it's easy way to remember, right? Next is delta Q. If the heat is absorbed by the system, it is gain, so positive. If the heat is released by the system, it is loss, so it is negative. And next is for delta U. If it is positive, then there is an increase, then it is positive. If there is a decrease, it is negative. And always remember, for a cyclic process, your change in internal energy is equal to 0. That's it for the day. So we have learned lot of things today. What is first law of thermodynamics? What is thermodynamic process and how to find work done for them? PV diagram and sign convention. So these are the most important and basic things to do problems in thermodynamics. So in my next video, I'll be doing problems related to this topic. So until then, keep practicing. Thank you everyone. Have a nice day.